Let's start with one of the most important building blocks for product sketching, our proportional square. And we're going to exercise this first in one-point perspective. So my first step is to decide, how do I want to draw my object? Do I want to draw it actually from the top, or do I want to draw it from below? So for example, we say that a horizon line is equal your eye level. So everything that's actually above your eyes, you see from below, and everything that's below your eyes, you see from above. So the same we can assume actually for the horizon line. Everything I construct above the horizon line will have the feeling like I'm looking from below. Everything I draw below the horizon line will look like I'm looking from the top. Now, because I would like to draw everything from the top, I have, in this case, to put my horizon line on top of my page, so I have a decent amount of drawing space. So here, this is my horizon line. Then we can mark somewhere a vanishing point. And I would like to start drawing or constructing my square perfectly centered in front of my eyes. So it has to be perfectly centered below the vanishing point. From the vanishing point, we can draw a line down, which has to be perpendicular to your horizon line. Okay, so now we can decide where on this line do I want to have my first square. And I'm going to put it down here. So my first step, actually left side and right side, is trying to estimate that these two lines are equal. So it's really important because it's like left side and right side. Okay. Next step, from the horizon line, the vanishing point, I draw each a line down to the left and to the right end of the first front line. And this one, for example, can help already to establish, to see if your first two lines you drew are equal. Because if this triangle, for example, looks like this, then you see those two triangles aren't symmetrical. So obviously these two lines, so this one and this one, are not the same. Okay. So there, for example, I feel actually that line is a little bit too long. So I'm going to adjust this just a tick. Yeah, this feels better. Okay, so let's see what we have so far. We actually have established our first line, and that's the front line of our square. The problem in perspective drawing when we deal with squares is simply the fact that in 2D, all these corners are 90 degrees and all sides are equal. But that's not really the case in perspective drawing. Maybe the front line actually remains the same, because in 1-point and 2-point perspective, we simplify the fact a little bit to that only what goes to the vanishing point foreshortens, so shrinks, but all horizontal as well as vertical lines don't foreshorten. So that means basically in perspective, I can't take this line and basically measure it along the diagonal. That doesn't work. I have to kind of guess that in perspective, the sideline will be a little bit shorter than, for example, it would be in 2D. And that's a tricky part. So let me do some extremes. So obviously that doesn't work. Now it looks like my rectangle actually is squeezed together. This also doesn't work. Obviously it looks like my rectangle is being stretched to the vanishing point. So maybe something like this. Maybe. I'm not sure if it's correct actually. The thing is, your eye can really be easily fooled, and to combat that, it's really helpful if you create yourself out of paper a square, cut it out, and then rotate it in front of your eyes so you can see when you take a look at it perpendicular like this, and when you start rotating it at one point, for example, when you look tangent to it, all you will see is just a line. And when you rotate between these two stages, you will see how this distance actually changes. And that's really very, very helpful, because that's what I need to guess here to be able to actually draw this line. Okay, so let's assume actually this is okay. And let's put down our left and right edge. And there's our first proportional square in 1 point perspective, perfectly centered at the vanishing point in front of us. So let's go back to this one for a second. I would like to make a transition inside my drawing from something like this, what we have here right now, to closely to something like this. So this line actually, if I want to construct a square that way, then zip, that piece would be somewhere there, directly on my eye level. But I would like to draw this one so I still can see a little bit the top face, but it's nearly flat. So to do this, from this point, I simply draw a line up, and from there as well. Because this way, what I have already is now, again, the same front edge. And then from this point to the vanishing point again, I can put down 2 lines. And those, for example, describe the left and the right edge. And for what's, for example, good to pay attention to right now is you see actually how these lines changed their degree. Now, if you think about the angle here between, so the more something goes to the vanishing point, the more this collapses, the more this line gets away from the vanishing point, the more actually this opens. So the tricky thing is now, and again here I need to guess the distance. So preferably something like this. Let's ink this quickly. Yeah, looks like a square, but it's not really correct. And I will show you that in a second. So something like this obviously is not good as well. So let's say maybe I feel comfortable with this result. Yeah, maybe. So you see that actually this distance is dramatically bigger than this distance. Okay, so I could assume, yeah, maybe that's correct. There's actually a way we can check this. So I have my front edge, my side edges, and I also have my back edges. So if I draw a straight line up, where these lines actually hit those diagonals, this back edge actually has to be. So there we can see that I guessed actually the foreshortening incorrectly. I made the square too deep. And that's again really the tricky thing when you rotate a square from this stage to this stage, because it really collapses step by step. And again, that's difficult to know at the beginning, and the easiest way is have a sheet like this, like a square at hand, rotate it in front of your eyes so you can see how it actually has to look. So I'm backtracking till this point, and then I actually construct these lines up, there and there, and take a look what we have. There is actually 2 squares in 1-point perspective. And if I connect these lines, you even can see there is also a cube in 1-point perspective. Obviously, this cube is not proportional. And I hope that basically this demo showed you to a certain degree how, for example, there is a transition between, if you see something really from the top, then you have to draw this rectangle far away from the vanishing point. And if you have a more shallow angle onto the object, then your object has to be closer to the vanishing point. And that's basically how you control this illusion from seeing something from above or more from the front. From here, it is actually very easy now to create a proportional cube in 1-point perspective. Again, in 1-point and 2-point perspective, we simply say that verticals and horizontals are the same. They do not foreshorten. Only lines, for example, that go to the vanishing point foreshorten. So you see, for example, that this front edge and this front edge, same length. This and this, same length. So knowing basically that when I have a square, the width and the height is the same, also in 1-point and 2-point perspective, I can literally measure this line and simply project it up. So let me try that one. So here is my front face, for example. So should be somewhere there. Okay, good. So roughly like this. Having this done, then actually from this top corner to the vanishing point and this front top corner to the vanishing point, and you see it cuts there and there. So there we can put in our missing back edge, and there it is, our proportional cube constructed in 1-point perspective.